Welcome all our members. Now we are starting our webinar. I request Yuvraj Ahuja to introduce our welcome speaker. Dhanu Patell webinar. Requesting you.
I can call it.
Thank you.
Doctor.
Okay. Good morning and a very warm welcome to all of you. A big thank you to ROMA and management for giving me this opportunity to introduce today's speaker. My name is Yuvraj Singh Ahuja and I am the director at Frontier Polymers Private Limited. This is ROMA's 16th webinar. Today is a special day for me as I get to introduce to you a person whom I not only look up to and respect a lot, but also someone who is regarded and loved world over for his wealth of knowledge, experience, and his warm, caring nature, not to miss his affable smile and laughter. I've known Dhanu Patell since I was a child, and I have many fond memories of him as my uncle. Dhanu Patell is a director and co-founder at Reinhardt Teknik, under license from parent company Reinhardt, Germany. It is no secret that Reinhardt roto machines are regarded one of the best rotational molding machines in the world, with installations in over 40 countries, including some machines running on electric and hydro energy. Reinhardt India specializes in full turnkey projects from concepts to final product, including specialized molds and auxiliary equipment. Together with his other co-founder and partner Shivendra Singh Chawla and his son Rustam Patel, Reinhardt Teknik's combined experience is over 100 years in providing effective solutions to the rotational molding industry. Dhanu Patell is an electrical engineer from MSU Baroda with hands-on training experience in Switzerland and Germany. He has over 40 years of practical experience behind him. His customer-centric approach has made him many friends across the globe. He has helped many customers forge long-lasting partnerships with leading manufacturers around the world. He is a team man and is known to help people in their dire needs. Besides work life, Dhanu is also a loving husband, a father, and a grandfather. I consider this my privilege and honor to be introducing him for today's webinar. Please type in your questions in the chat box. Questions and interactive sessions will follow after the presentation. Now, without further ado, it's over to Mr. Dhanu Patell for today's webinar.
Done, sir.
Hi, everybody. Good morning to you. And nice. Thank you very much, Yuvraj. You almost brought tears to my eyes, my friend. We look to our younger generation today to teach us many things. And of course, many a times we hear that whatever we did till today is wrong. And I think that's a very good feeling to hear that, you know. It means that we must have done many things wrong and we need to change. So what we love to do today is hear them out, not with 2 years, with 1 year, because the other one has to be kept sometimes to filter some things. But at the end of the day, when we listen to what they have to say and we give them a free hand, this younger generation really does wonders. Yuvraj is a typical example. He grew up as an architect in front of my eyes, and he's done wonders to the company. And so has Rustam. So this is really nice. Thank you for the introduction. The topic I chose was back to basics. It's because we all are in a very fast world doing many things. Corona brought us back to our size, cut us down to size, made us sit down and think what life is all about. And it's not just about doing things quickly, faster, better, more efficiently. It is also about evaluation of time with our families, with the work we do, with the people that we grow up with our employees, with everybody around us. So I thought maybe a little bit of mix of basics in life would be good. and that's how I chose this topic. Essentially, what we'll be doing is running GMP, wall thickness, safety, customer management, service, new products, and at the end of the day, no questions, please, because I may not be able to answer any of them. In terms of good manufacturing practice, today's, I think, most important question everybody asks, what is new and what is automation that we can bring into rotomolding? Because all said and done, in the plastic industry, rotomolding is probably the slowest process. Everything else runs within seconds or within maximum a few minutes. However, rotomolding runs in maybe 10, 20, 30 minutes, even sometimes to an hour to bring one product out. So the problem is, what comes first, the chicken or the egg? Most of the time, if somebody asks me that, I tell them it depends on what you are eating. If it's breakfast, it's eggs, and if it's dinner, it's chicken as the first. So to give you an idea of what my concept of life is. Then we also look at GMP, because some very useful, simple tools are there towards a step, towards automation and that, which most of us forget when we get into the running of a company. Because we rarely go down to the shop floor, we rarely look at the problems that exist with the workers, their supervisors, how they handle things and that. And if we really went back down today in management to work with our workers, to install a machine, to run a product line, to do anything, you would realize the real difficulties that they run into. So first thing we need to look at is in GMP is how to actually change or help them to work better and faster. Then I'm going to do a little bit about wall thicknesses, something about design and machinery parameters, and process control. Now, there are a total of 46 slides. Anytime the management ROMA wants to tell me to stop at any given time, please tell me freely and I'll cut it short. Okay, let's get on with it without much ado. Simple thing to look at is clamps on your molds. How many people still run with nuts and bolts and rattle guns, which make tremendous noises and throw out a lot of air? Sometimes they're dangerous to the workers' eyes and that. Can we not replace these nuts and bolts with clamps? Or to start with, he says, always the worker tell you, sir, the flange leaks and the flange is bent. So why not put partly nuts and bolts and partly clamps? These are some different types of clamps. If you want to go to the next level of automation, you can always look at something like this, which already Oliver has shown us in his earlier video, ROMA. Now this is really a high-tech spider with some pneumatic clamps which work at a very high temperature. So this is going into very full high automation level. So it's interesting where you can start and where you can enter. If you have the money, the output, that is required for the number of molds that are going on. Spider, henses, work in seconds. Ordinary clamps will give you maybe a minute, but at least you're getting towards that level of output. Powder loading systems. Everybody's question today or problem is, why do I still need to load manually? Why do I still need the man to go up there and throw the powder into the mold, especially for people who make multi-layer products? Single, double, triple. I just got an inquiry for a machine for 6 layers. I really don't know why he wants 6 layers, but as a machine builder, it's our job to provide whatever they want. So if they want 6, 8, 10, we give it. But I think it's really crazy to do this. People in the European world and the North American world, including Africa's, have never heard of foam in tanks. In the Middle East and in India, foam tanks are like every second factory or almost every factory would be producing a foam layer tank. So it depends regional wise what is the demand. Powder loading systems, there are plenty of people now in the market, but most of them have specialized in conveying of powder in PVC industry. In the rotomolding industry, there are very, very few people who are specialized. One of the top guys, I think, in loading is a company called Roto Loader in Canada. He has dedicated his entire powder loading system just for rotational molding. So that is somebody exceptional. Then you have now Conair, which is an American collaborated company right here in Ahmedabad. And he also specializes in powder, but that is also again mainly for PVC. But he says, tell me what is rotomolding and how do you want to use my system? So he's somebody again who has probably never seen or done it. But if we could buy his receivers and dispensers, we can easily adapt this system into our machines, into the existing machines. I cannot do it as a machine builder, is because everybody's factories are different, everybody's budgets are different, everybody's mold size are different, everybody's port of loading is different. So that is why it normally has to be done by the customer himself. We can help anybody that they want. Then there is another company called Penta. This is also basically an American company, but their powder conveying system is done by one of the Italian subsidiaries, and they are also now based in India. They're in Mumbai. So to give you an idea, that powder loading systems are now available. You can see on the right-hand side a very, very big system, mainly for PVC pipe extrusion and that. The middle part from Conair is just the receiver of powder. So it's basically a cyclone which puts powder in. It has a pneumatic valve, and based on a timer, it will dispense the powder. The problem here is you cannot dispense really powder in rotational molding by volume. Ours is not a continuous process. We need to process and drop powder by weight. So we need to add a gravimetric loader to this instead of just being a volumetric loader. Just to give you an idea. On the left-hand side, you can see Rotoloader Canada. It has got different steps of automation, a very simple loader to a very complex loader to multiple color loaders and that. And somebody should really try this out because it's not that expensive from them. We did help somebody on powder loading systems and that, and they wanted to put in very fancy silos made from stainless steel and that, which were almost the price of maybe half a machine. So we said, but you are a rotomolder, you can easily rotomold your own silos and connect them up. And that's how it was done. Saved him a lot of money. The other thing that people today also I see when I go in many factories are they're trimming mostly with hand shavers, or they're trimming with a hacksaw blade which has been sharpened, or they're trimming with even old scissors and that. And it's rather surprising because today a simple tool like a router is available so easily, which can trim a 2-meter part in maybe just a few seconds. So you can see how quickly it is. Routers are available off the shelf. Routers are quite safe to use, but they are very, very fast. So just with a little bit of guarding, you can easily do a lot of work with it. That was a basic hand router. Here we start looking at routers with a slight improvement. Is the volume too loud? Can you guys hear me?
No, there is no volume in this.
There's no volume coming through?
No,
Is there no music coming through?
no.
Okay, then let's just look at a silent movie. No volume. So this is how easily you can extend the human arm into the water. If you go to the next level of routing, which is probably another step towards automation, is using a small little robot. This is a Kawasaki, Yasakawa. You can buy a Kawasaki. You can buy a Fanuc. You can buy a Kuka. They can't do it. The advantages of these routers are they are programmed properly. They do the same job again and again and again, and you don't have to really depend on the worker so much, whether he trimmed a little less or he trimmed a little more. Can you guys hear me at all, or even my voice is not coming through?
We can hear your voice, but there is no volume in the video.
Oh, all right, fine, that's okay. You'll have to make do with me without the music. No problem. So you can see how quickly this little robot, which is mounted from the top, not from the bottom, can do an excellent trimming job. You can buy today plenty of second-hand robots in the market. They're reconditioned, available very cheap because a lot of automotive industries have shut down or have changed their technology and they've got improved version of robots. Simple little, really going back to school, I would say, is vertical boards are a must in every factory. Get rid of your horizontal tables because all that the horizontal table does is collect dust and everything is literally dumped on it. If you have a nicely organized vertical board instead of a horizontal board or even an inclined board, that will do the job. It will stop people from putting stuff into it. If you look at this little video here, this is a spin welding process. Here there are spin welding fittings on top. One sec. These are spin welded fittings and the finish of that. And here you will see how the spin welding process is done. This is again using a router. And in a matter of few seconds, you can put in female, male, any kind of fitting, which is bonded at high temperatures using friction. So basically what you need is a correct polymer fitting, a good routing gun, which operates at maybe around 20,000 RPM minimum. And then as soon as it's molten, you just push a little bit and boom, it's done. The job is over. It takes about 5-6 seconds to do one fitting with this. This is something I learned from Gary Latigan, who is also one of the mentors of our life. Not me alone, I think hundreds of people in the world and thousands of companies, I would say. He used to tell me, I'd never understand why people make a good product and dump it on a floor where there's dust, it's cold, it's bad, it's ugly. Why don't they put it on a pallet or a wooden board or a rubber mat? And believe me, it does make a big difference between winter and summer. One is the product doesn't get dirty. Second is because of the cold floor, you get warpage wherever the surface is coming in contact with the floor, whereas the rest of the part is still cooling, because demolding hot is definitely the way to go. Here are some different, any pallet which is second-hand, used, anything, even the wooden pallet is fairly cleaned, which can be put where the product can be put. Here you find this company putting a steel frame at the base of the part immediately as soon as it comes out, while it cools for the next 6, 8, 10 hours, sometimes even 12 hours, so that there's no deformation, and the mounting subsequently on the vehicle is perfect. So just a small tip for someone to know what it is. This is again the same thing, stackable cones for the mining industry, nicely, neatly shrink wrapped as soon as they come out, put on a pallet after trimming with a router, ready for dispatch. Let us look at how many of our companies are using platforms. Always the problem is the fight between space. For people think it's a waste of space, or you actually start life small in a small company and you grow slightly bigger, then you grow bigger and bigger and bigger, but you want to still do it in the same space. Which means what? The worker who has to manage the machine or load, unload the part, he tends to get cramped further and further. Your shop floor becomes a mess. If you plan a little bit better and you give him a proper platform to get onto with proper guarding and that, the biggest advantage would be that you would get better output from him. He would get less tired, would have less rejection. Whatever we do in terms of automation, these two hands that we have and the head sometimes, which is there, is definitely still the best option for loading, unloading, and perhaps the cheapest option. We are lucky in India. Our labor costs are not that high. They will get high one day, but till such time, I think the best option is still a human being, a good worker. He wears a proper helmet, he wears gloves, and he operates, and everything is good for him. Let's get down to the biggest, the most difficult question in rotomolding, which is wall thickness. Wall thickness is a function which has to be built into the part, right from design stage, right from the heating airflow stages, right from conductivity of the mold, whether it's steel, aluminum, and that. Of course, radiuses, ribs, and process control, machinery parameters come into play at every stage of this. Mind you, wall thickness in rotational molding is defined as minimum wall thickness. It doesn't mean if somebody specifies, an automobile industry specifies that I want my tank to be 6 millimeter uniform, I don't think he would ever get it in the rotomolding process. The smoother the radiuses, the corners, the less variation, but still there will be variation in wall thicknesses. So it is for us to use this higher thicknesses on the radiuses and strengthen the product. The biggest advantage we have is we can put a variable thickness as and where the design demands it, where we are mounting something or the other, or where you've got inserts, or where you've got a stress point and you want to increase the thickness. We can easily do that, whether it's by process control, or it's by design to begin with, or it's by a machinery parameter. Simple logic, wherever there is more heat, you will get higher thickness, provided there is material left in for the other coverage. Because in most of the times what happens is people want to make a very lightweight product. Lighter the better is the norm, because lighter means more money in your pocket. But you forget that if you put a very light shot, the powder gets consumed also very quickly, And the fact is, if the powder gets consumed very quickly, wherever is the hottest point in the thing, it gets into a shortage, a well of powder is accumulated there, and it gets into short supply for the rest of the parts. So you will get a very thin wall, maybe 2 millimeter, 3 millimeter, and in some parts you'll get a very thick wall, 6 millimeter, because the airflow of the ovens is not right. The rotation speeds are also critical. So keep that in mind. Wall thickness by design, extremely critical topic. You are looking at radius, width, thickness variation, foam, things like that. Now, I would like to explain to you that these are guidelines where kiss-offs are concerned, where you want higher thicknesses. You can also have kiss-offs, right, which are called near kiss-offs. They are not really touching the top surface. In the boat industry, near kiss-off is used a lot. Why is it used so much? The reason is that you want the hull of the boat to be slightly flexible. You don't want it to become like a rigid piece of steel, because when the boat is going fast and the water is pushing it, you want it to work like a shock absorber. So you will create actually a gap instead of a real solid kiss-off. This is a near kiss-off by design. Critical, important. What we've got here is various simple thumb rules of kiss-off features, which is normally 1 point, the gap should be 1.75, the thickness that you want of the final part. The mold, whether it's aluminum, steel, stainless steel, anything, it doesn't really matter. If you have foam built in, that please keep in mind, the foam will expand and push the kiss-off all the way up to the point where on the top surface you will have deformation. This is PE foam. The same thing can happen with PU foam later on. Therefore, when you're using PU foam, the jigs and fixtures are extremely important. Recommended radius is, when you want to do a 90-degree turn, is 3 to 13 millimeter. Right? But still, you will always find thinner on the inside and thicker on the outside. So you can look at this diagram, keep it in mind. That's why I call this presentation back to school. Most of us forget these things when we design products today, or when somebody comes to us with a piece of steel part and say, I want to make this into plastic. And there is a difference between plastic and steel. The way the material will flow will be totally different as compared to steel. So we have to make him understand that. Look at the variation here, but this is an excellent part, because this thickness change in this part, in this area. Let me explain here, this one. This is being done by design. And this thinning that you see slightly is also by design on the other side. So this is actually a very, very well designed product. Look at this. Perfect parts for special projects, perfect thicknesses on the edges to give it strength, because those are load bearing. This is PU foam, but look at the wall thickness here. This cannot be helped because this lip will always catch more powder during rotation, whatever you do. So you will get a slightly higher thickness than this, but you can use it to your advantage. Here, this is PE foam, using it for kiss-off. This is a very, very deep cone, as you can see. This is being built in many parts of the world on our machines. It's basically a cross section of a floating jetty which can take a very heavy load. And the beauty is that this entire cone formation inside is just being manufactured on a normal machine. There is no additional heat amplifier. There is nothing here to help him. But the trick is in getting the airflow in the right places and in heating the inner cores the way they should be without much help compared to the other parts of the part. So you get a very, very uniform thickness here also, as well as here. The thickness here and here, the difference is really very small. We are talking of about 1.5 millimeters, which is remarkable. Some of this data and slides and conclusions that we have learned or come to are derived by world-renowned experts. I think the first name that would crop to anybody's mind is Professor Roy Crawford, because he has really been like a father of rotational molding. He taught us in the years that he lived, right from, unfortunately, it was a big loss when he passed away, to the industry, to the process. He put us on the world map, whether it was North America, whether it was New Zealand, whether it was Africa, whether it was anywhere. Professor Roy Crawford became a professor, I think, in the Queen's University of Belfast, where most of the names that you see have graduated from. Dr. Paul Nugent is another remarkable person who has been a world-renowned consultant, as well as also from Queen's University of Belfast, a fantastic fountain of knowledge. Dr. Gareth McDowell, another doctorate from Queen's University of Belfast, and is selling, I think, 493K internal measuring equipment plus magnetic thickness testers and things like that. And of course, the one and only Gary Zatigan, who today is right here at the seminar. We must acknowledge their hard work of so many years in trying to promote the rotational molding industry, because that is all that they have really done, is help us, put us on our right paths, guided us. A lot of things in machinery, machine building, in development, comes from experience and knowledge of these people. There is one more name which I should not forget, and it's not listed here, is Glenn Beall. He is also from the US, a bit far away from us, a bit reserved man, but I think he too wrote many books and put in a lot of effort in putting down various guidelines for this. One of the basic guidelines for knowing how to control wall thickness and what will the end result be is, if you read this carefully, at the first time you may not understand what it's trying to tell us. If you read it the second time, you'll understand maybe 10% of what it's trying to tell us. If you read it for the fifth time, you will start understanding what 20-degree angle can do, create actually an air pocket here. One sec. Right here, can you see this air pocket here? It can create an air pocket here, a bubble, which is a weakness. So from the outside, this rib would feel excellent, very thick and everything, but because it's very sharp. Now, by design and a lot of underground products, today you have to design this rib to 20 degrees so that you get a real solid rib over here, which is a strengthening rib. And it works very well. But of course, you must make sure that you don't get air bubbles in it, no entrapment of air in it, because that becomes a weakness in that solid rib. Now, why does this happen? I remember learning in my very early days, everybody said the powder is not 35 mesh, therefore it doesn't work well. And gentlemen, if the powder is not 35 mesh, it doesn't work. If it was all 35 mesh, you would get a very, very big hole here. Not a small one, a very big hole here. In the powder mix, you need the right mix. Different sizes put together. It's like our fingers of a hand. If you had all the fingers of the same size, you would have difficulty in picking up something. If you had all the powder of 35 mesh, it would not fill up all the small corners, crevasses, gaps during rotomolding. Therefore, you need fines, you need semi-fines, and you need 35 mesh also together. So these are guidelines that all these learned people taught us and what to do. If you go to 45 degrees over here, you will find that you get a more solid rib, but not as deep or as long as you would want in, as for your design. Because today when you do FEA, this solid rib on the drawing will give you tremendous strength. This will give you lesser strength. When you get to 90 degrees, you tend to come towards closer and closer towards the uniform wall thickness. Even then the radius here, when you look at the cross section, you will have a thicker layer there. If you go to 120 degrees, this is what happens. What makes a perfectly uniform wall thickness? Obviously the round circle, because our process rotates biaxially. These are again numbers given to us by learners. Basically it says what should be the outside radius and inside radii for polyethylene and polyprops. Today a lot of moldings have gone to polyprops as the demands are going up for higher service temperatures as well as higher stiffness and higher strength. So polyprop powders are now available from Matrix, from Rotoworks, people like that, and they are doing well. Polyethylene, this is also a guideline. I'm sure ROMA will be giving you a recording of this, so please keep that printed, keep it, you can refer to it whenever you are doing something new. Ribs and thickness variation. Again, explaining to you how a rib design is the starting point of a rib design. Basically, if T is the thickness of the wall and you want to create a rib, you should not go more than 40. If you go more than 40, all you'll be doing is creating a well where the plastic will get entrapped. What should be the gap? It should be 5 times the thickness. This would be an ideal rib. If you made a tank and you made a tank without any ribs. In Australia, mind you, there are many tanks without ribs, but the strength of the polymers are higher and their height to diameter ratios are different. The domes are different. Therefore, they do withstand even 10, 20,000 liter tanks. But when you go for lighter sections than that, ribs will give you additional strength on the side. So this is something that you keep in mind. Look at this section. This is compliments of my good friend Shwetang. This is produced in Constacool, a very complex part used in the refrigeration industry. Look at the thickness that he could get on his machine over here with a lovely mold, and a very, very difficult molding to do. But I think every time it comes out perfect. FEA analysis. All standards today of any credibility, I would say, or all big companies are going to eventually ask you for FEA analysis of the tank that you have manufactured and given them. How can you tell me that a 8 millimeter wall thickness is enough for my tank? Because he's going to be storing not only water, he could be storing hydrochloric acid, nitric acid. He could be exploring. Yesterday, I had somebody talking to me for guidance on sulfuric acid and phosphoric acids. And he really wants to be sure, because today if there is an accident, there's a leak with acid, my God, your factory is as good as shut down. You have to forget it. So one really has to be careful where you give your tanks to, and what are the parameters that he cannot go beyond. Normally people tell you that, oh, it's going to be ambient temperature. It never go over 40 degrees, 45. And sometimes when you are working with chemicals and acid and you find the tank has deformed from the top or from the side, and you go there and you just measure it with a simple temperature gun, you find that the service temperature has been 80 degrees. Obviously LLDP will soften at 80. So that's where PP applications will come in. 1/3 from the bottom. As you can see, 1/3 from the bottom here is always where your hydrostatic pressure is the highest. What do we tend to do as novice tank manufacturers. We say, we kick the tank on the side, we touch it here, and they said, and the dealer says, देखो कितना मजबूत है, एकदम strong tank है, इसको कुछ नहीं होने वाला है. He may have missed this point, where actually he is thinning of the wall. By the way, that is one of the biggest issues with blow molded tanks, because you always have thinning towards the bottom and thickening towards the top, since the Patterson comes from top to bottom by gravity. So I'm not going to go into that at this point, but this is what it is. So 1/3 down there, really be alert. The bottom is normally fully supported. There's not much of an issue. The top, because the guy, the plumber, is going to walk on top, make sure it's strong and stable enough to take his weight. There are many standards now coming up, ISI and very, very heavy tanks. Sometimes I think over-designed, but okay. This is some underground products. This is the kind of rib I was talking to you about earlier, which forms a solid deep rib. It's about 125 millimeters on the top here and about 60 millimeters down here. So you can imagine creating a product like this without a single fault with really solid ribs. This can take a lot of earth pressure. Even a truck can go over it and you won't have a problem. It's a septic tank. This is a pumping station in Latvia. No, this was in Norway. Mold made by us, again, one of our customers in that. And it also has solid ribs in that. Very, very good product. This shows you more detailed. This is in Australia, global. Sometimes you do get some sink marks because the plastic is very thick here and takes the longest to cool. And if you look at warpage, you also may have slight issues, but if the product is going underground, there is no need to reject it straight away. Process controls, again, a parameter that everybody tends to ignore and either blame the operator or blame the machine. So it's always easier to put the ball on somebody else's court, especially when you get a rejected part. Airflow, critical, amplifier, critical. This is again a fish box, which is very difficult to mold. It's double walled, it has some cavities in here, it has to stack 8 high. So you can imagine if it's a 1,000-liter fish box and it's going 8 high, you're talking on the bottom fish box, a load of easily 8 tons vertically stacked. A really critical product. That is why everybody cannot make it. There are only a few companies who take lead in this. Polymer is critical, design is critical, process control is even more critical. Internal mold, air temperature measuring equipment, very important for this. If you could heat the part from all 4 sides with exactly the same strength, you would be able to make a part very fast. That's why the airflow is again critical. What is an air amplifier? An air amplifier is something that takes a little bit of compressed air through here, throws it into a venturi, and sucks a huge amount of air from the other side. So what you have is a little compressed air coming in here, going through a small little slit here, flowing very fast out. So because it's creating huge amount of negative pressure over here, it is sucking nice hot air from the oven and throwing it into a deep cavity mold or a part of the mold where the hot air cannot reach. Now it not only takes hot air from here, it also, because of this high-speed air coming out, sucks more air from other parts of the oven or the airflow and pushes it towards the part, getting a nice thicker wall where earlier you had a paper thin wall. Again, very useful for double-walled deep cavity containers. This is something that has come up into rotational molding, I think, in the last maximum of 5 years, not earlier than 5 years. This is a partly vacuum heat pipe, which has got a little bit of water in it, a special wick. And what it does is this part, half of it sticks out in the oven of the mold. And it conducts the heat very, very quickly. If you have been to different exhibitions, you will find that people are selling a lot of heat pipes. Mouse is one of the leaders in it, but now there are many more manufacturers. And they will take a coffee cup and put a heat pipe into it. And in less than a second, the other tip of the heat pipe will be so hot, you won't be able to touch it. So that is how they create a through hole in a part, which you think is almost impossible to rotomold. Where is there any maintenance on a heat pipe? It's a completely sealed unit. It's partly vacuum. It's got a wick. It's got a little bit of water in it, and it is high conductivity material on all sides. Profit pins, again a mouse invention. Basically, heat conduction takes place with surface area delta T of temperatures of air and the mold, the difference in temperatures. So if you give it more surface area, the mold has the opportunity to catch more heat. So what you do is, when you are trying to make a very, very thin wall product, like I think this is a planter mold, so the wall thickness may not be more than 2.5 to 3 millimeters. How do you get it? Otherwise, the part will burn if you try to work. Anyway, the steel or the aluminum to polymer ratio is ridiculous. You're talking of perhaps 20 kilos of metal and 2 kilos of powder, or even sometimes half a kilo of powder with 10 kilos of metal. So in order to get the heat uniformly distributed all around the mold before the powder is over, what they do is they create these pins on top of the mold. It's a cast aluminum mold. And that way they give you additional surface area for heat transfer. Bimetallic molds, again something which is not being used very commonly in India, and that when you have deep cavity double walled, why not make the inner cavity using brass or copper sheet? And I can assure you the thickness here and outside will be almost the same, and you don't need to spend any extra time in the oven. The conduction is much, much faster and easier. This is parts of a mobile toilet. This is being built in Turkey on our machine by Jalal Basil, from whom I learned a lot in bimetallic molds. He uses brass pins, brass ends and things like that on these molds. And the parts were coming out perfect, zero rejection. Earlier, if you made 10 parts on this, and at least 2 would be rejects because it would not form properly at these ends, because you need a higher thickness there where the pins are located. Machinery parameters. Rotation ratios, vectored air and temperature. This is our strength, I suppose, but still guideline on process rotation ratio only depends for telling the operator, or you do it by your experience, it will come out okay. Carlo, why? Because you really have nothing as a guideline to tell him how to go about this. You have not been an operator all your life. Next is, how is he mounting the mold? If it's a vertical part, a vertical cylinder, is he mounting it vertically? Is he mounting it horizontally? Depending on the swing, what does he have? Is 4:1 ratio uniform, perfect for everybody? Well, all the pundits, all the gurus taught us that 4:1 is probably the best starting point. I'm sure years of work in the Queen's University of Belfast and probably in somebody's kitchen went into coming to these ratios. I don't know how many of you know that rotational molding had started in the chocolate factory. The first rotomolding machine was probably made when you make Easter eggs, where chocolate was poured in two halves of a vessel, put together, and rotated on a simple stove, on a simple heater. And then somebody thought about it, that why not I use polymer granule in this and I can mold something hollow. And then he tried granules and he said, oh, this is taking too long and it's not uniform, so why not go to powders? And that's how the story of rotomolding started. This is a standard. This would work beautifully with 4:1 ratio, no problem. But you have told the operator, I have only got a straight arm free and I want you to make this. I don't care how, I want my production, I have an order, I need 3 of these to be manufactured at one time. Do it somehow. You think he can do this? No, it's crazy. If he does that, you'll have all 3 parts rejected. Here are some guiding numbers for machinery parameters to start with, depending on the geometry. So this is a starting point for you all as to what, with respect to the size, what is the ratio you should run. In most cases, 4:1 will work. 4 on the major axis, which is the arm, and 1 or around 1.2, 1.5 on the minor axis. Now, if you find with that your thicknesses are not coming at the right place, it could be, I'm talking of a simple vertical tank, it could be that your airflow is not right. It could be that the base and the mounting flange gap is not enough, or it could be that you are punching in 4:1 ratio in the machine, and actually when you measure it, the machine is giving you maybe 3:2 or something like that. So you have to really keep an eye on this. This one is important. Please take a print and keep it with you. And the next slide I'm going to show you is a very critical slide. It's slightly everything on one page, I would say. Let me put it that way. It's all together. We are talking, the problem is in rotational molding, the laydown of the powder or the fusion of the powder takes place between 85 and 130 degrees internal air temperature. So how are you going to find the internal air temperature? So please talk to Gary or Gareth or somebody, and they will guide you on what equipment you need on your machinery. It can be just a probe, it can be a nice radio controlled telemetry, communication telemetry, or it can be an infrared gun, but there can be something to tell you what the temperature of the polymer is inside and when the powder is over. If it goes more than 130 degrees internal air, there is literally, I'm sure, no powder left in the mold. So after that, whatever you try, you are really only curing your material, but you're wasting your time on trying to put the powder in the right place. How do you start? How do you, sorry, did somebody mute me in between, or did it just happen? I don't know. Hello? Hello?
Unmuted.
Yes, sir, you
are audible, sir.
All right.
You are
Sorry for the break, but suddenly I got a message on my screen saying you are muted. Anyway, I thought you had enough of me. Anyway. Now, if you get a new mold and you're a custom molder and you want to start thinking, it's a very complex mold, it's double walled, it's got many undercuts, it's got some inserts, it's got everything. What is the ratio you're going to tell your man to run this mold at? So what ideally is to be done is that if the mold wall thickness is, targeted thickness is 10 millimeter, the first shot you should take is a 2 millimeter. So pro rata, you bring the kilograms down and you run a part at 2 mm wall thickness. Then you cut it open and you check that you've had the right thicknesses wherever you needed them. Once you have set your parameters right, then you increase the wall thickness, increase the shot weight, and run it for the right time. And you'll get a perfect part. But from the day one or from the beginning or first run, you will not be wasting kilos of material. And nobody will be there to tell you as to why did you produce 10 parts of this and then realize that you're not getting enough thickness in this position. So keep that in mind. This is a very important slide. Compliments to Dr. Garrett and that from 493K. It gives you almost everything on one screenshot. This is another very important slide from Gary. Roto Solutions provides excellent consultancy and gives very nice service and equipment for internal entertainment. Of course, you need a keg of beer with it, otherwise it doesn't go. This machine runs on beer. Powder lay down area has been shown here. Important. This is the time critical period, what I was telling you earlier, between 130 degrees to 85 degrees, where the powder layup starts. This shows you the peak internal air temperature, where it's curing. This shows you how well your oven is running, how fast your temperature goes up. And this shows you your cooling graph. Many people have asked me many times, what is the ideal rate of cooling? Well, the ideal rate of cooling in a lab would be 10 degrees a minute, for example. So he says, okay, so I have reached 205 degrees on my part. I pulled it out. I get 10 degrees a minute, maybe for the first 4 or 5 minutes. And then I get only 5 or 6 degrees of cooling for the rest of the cooling period. Okay, why does this happen? Once the part leaves the side wall, the metallic wall of the mold, you have created a gap in between the part and the steel ball. So you've created insulation there. So now the rate of cooling will become thin and you're only cooling from the outside. If you're using internal cooling, you will get your 10 degrees or 8 degrees a minute and your part will come out without warpage, without any problems, perfectly cured. Advisable not to start cooling the minute the part comes out. Give it 1 or 2 or 3 minutes because you don't need to really cure the entire part in the oven. You can save some oven time by getting to this peak over here, just outside the oven. Can you see here? Like that. Vectored airflow, or air where you need it in the machine. Most machines, temperatures are measured of air in some corner of the machine, maybe at the top, at the side. You put in 2 probes here and everything, and you can measure the air over here. Is there a mold sitting here? It's very easy to put a probe here because it's easy to maintain and it's easy to check if there's anything wrong with it and all. But there is no mold here. There is no mold here. There's no mold here. That's where PIT equipment comes into play. But you can also design the airflow in such a way that it hits only the mold and not the side walls of an oven. You don't want to heat up your side walls. They will eventually get hot over a period of time. What you really need is air where you have polymer, not air to heat the steel. This is airflow on all 4 sides. This is airflow only on top. This is a typical fast machine design, which has the advantages of independent arm machine being totally flexible. You can run, though it's a fixed arm machine, it has the advantage of an independent arm machine and the advantage of a fixed arm machine, the speed of a fixed arm machine. The reason this is there is because the machine can travel any direction. The machine can load, unload at any point. There's a traveling oven, very easy for multi-shots. We think this is probably one of the best ideas that has come to us and is running very well all over the world. We have more than, I think, 350 of these machines running in the world. Safety, an issue which is totally disregarded in most MSMEs or small scale industries or companies which are far away from the eyes of the factory inspector or from the eyes of the factory management and that. As long as you get your pillows out, nobody cares what is happening. Today, safety priority has become our friend here with a mask. We also need glasses. So these two are really important. In addition to what we do on the floor. In rotomolding, ideally speaking, for an outside person, the best method would be to put fencing along this red line everywhere, put a few gates, and this is the safest machine in the world because nobody can go in there when parts are rotating, nothing can happen, so he's fine. But can we really run rotomolding machines with so much of fencing and guarding? Because we like to access our molds, we like to go and fill double shots. We like to go and touch the mold in between to see whether it's hot enough, cold enough. So what can be done? So you can have scanners, safety scanners over here in different segments of the shop floor. And that will control everything that is happening here. So if somebody walks in, this will stop. Somebody walks in here, this will stop. And that's how you run today. All the machines marked with C going into Europe, into America, into Australia. This is absolutely compulsory. Maybe not today, maybe 5 years down the line, it is coming to India. There is no doubt about it. And if you're working with a multinational or if you're a custom molder for the automotive industry, sooner or later, they are going to insist for all the additional safeties that are required on a machine. The basic safety that without spending money immediately that each person can do in your own company is marking the floor clearly. Which areas are safe, which areas are not safe for the guy to walk around it. It's really critical. This is a company in Africa with Top Tank. I don't know if you know them, in Kenya. They have 3 machines in a line and they have adapted very well to floor marking and safety standards, and they've not had a single accident or crash or anything, or somebody leaving a ladder in between, or somebody leaving a pallet truck or a bag of material when the machines are moving. And the brighter the floor, the easier it is for the operators to work in. This is a factory some of you may know, may not know, in northeast of India. And I'm very proud to see it and that because he followed each and every instruction that we guided them. But the outcome of the instruction was even better than what we had guided them. So hats off to them. It's running 24/7 for the automotive industry. An overkill of safety. This is in Australia. Australia is paranoid about safety and health standards and things like that. So what is an overkill? I would say this is an overkill. Such a high railing, a platform going in and out, and the person being able only to reach this part of the mold and nothing else. So every time he has to rotate the mold to access the other parts, he has to move the platform back. He has to wait, then he has to remove the safety interlocks, then he has to rotate this. It takes him maybe 1 hour to demold one part, whereas it would really take him not more than 10 minutes. So sometimes people can go crazy with safety. Be careful. What is okay, what is not okay is important. Risk reporting is a critical part of safety. And risk reporting actually helps you prevent an accident. So why are we going to wait for an accident to take place before correcting our method of working? So ideally the method would be to report a risk. Listen, you're running a high risk, and if you run a high risk, Please, we should not do this again. We should find the right height of ladders, or we should have a forklift with a cage, go up there and do the right thing. There are people who ignore everything, qualified, educated, experienced people, but they also sometimes consider that they are acrobats. I said, so what? We can do it. We've done it many times. And it works till the guy falls and breaks his hand. It works. Customer management and service is another basic tool which everybody has to understand and know. The minute you walk into anybody's company, whether it is to sell a machine, whether it is to install a machine, whether it is to give him a roto-molded part, or whether it is just to service something that you've given it, you have to know that you are one team. You've entered his gate, you and he, he's not the customer and you are no more the supplier, whatever his attitude may be. Keep in mind that you are going to get into his shoes and think, what is his problem? How can I help him? What does he really want to do with my equipment? What does he want to do with my roto-molded part? Can I improve or guide him very gently? Egos are very big sometimes, be careful. And you guide him the right way, you will never come out empty-handed. You will always be a winner. Fair practice. Be honest with him. Tell him the truth. If you think your price is too high, you can always explain to him the advantages of what you're giving him. You can always tell him the performance. You can always explain to him how you produce the part, what all goes into it, and he will get convinced as compared to another supplier. Tell him, if you don't make a small margin, you don't need to make a tenfold margin. If you don't make a small margin, you will not be a survivor in the market. So fair practice, it has to be the most important part. Be genuine and truthful advice. Don't con anybody. Conning does not help you. Conning is caught sooner or later. If you give truthful, correct advice, you cannot go wrong. Understanding difficult times like today, where cash flows are a big issue, where business is scarce, where people are not available, where people are not coming, they're working from home, you have to understand the difficult times. Luckily for us, in the digital age, things have changed a lot. We have the right tools, we have the right equipment to be able to communicate easily, to be able to share videos, to do everything. Today, I would be sitting in maybe talking to you all in a nice cocktail party, in a very nice seminar somewhere in the world. And here I am sitting in my boardroom and discussing this with you so easily, so nicely. So we have difficult times, but we have solutions for difficult times. Customer service. Is it a department in your company? If it is a department in your company, if it is a sales and service department, I suggest you please change it. It's an attitude. It is not a department. Every person in your company, when he steps into another company, is your company's face, is your company's representation. So if you coach him, if you train him with the right attitude, you are going to get the benefit of it. Training and bringing him, tuning him to the right attitude is really important. Service, when you say customer service, at what point and how much do you do for a customer? I think any amount you do for a customer is sometimes not enough. There are some very difficult customers in that, but how do you convince them? Good proper in-house designing, or referring to him to the right designer. Like we have a very good designer amongst all of us, is Satish Kople, Design Directions. They do some fantastic designing. Or asking the customer with a lot of experience as to his sketch, his design. From that, making a proper drawing and giving it to him. Subsequently, 3D modeling his part. You're bound to get the order. Making an excellent mold is not enough. From the mold, you have to give the tank as well. When we talk of servicing, it's 24/7 support has to be in real time. When somebody calls you in the middle of the time, you say, hey, it's a wrong time. Is it urgent? I will get up and sit on a computer and solve it. Keep in mind, for him, it may be morning 8 o'clock, or for him, it may be in the middle of the shift, and he has parts to deliver the next day. So you must help him out. We had a very, very experienced molder. He has our machine for 14 years in Australia. He actually woke me up at 5 a.m. 3-4 days ago. And I said, yeah, what happened? And he says, damn burner, stop firing. I've got a big issue. I don't know what to do. I have to deliver this tank today evening. And I'm really stuck. I'm sorry to wake you up. I said, don't worry. Let's see what we can do. So our service support people also are trained for that kind of help. And we did a lot of things. And at the end of it, I told him, can you show me the gas pressure gauge on a WhatsApp video call? And the gas pressure was 0. His gas tank, LPG tank was empty. And he said, I'm really, really, really sorry. He said, in 14 years, I've not had an empty gas tank. It's happened today. I said, it's okay. It won't happen again forever now. So that's it. Make products that need minimum service. So when you make a product, when you design a product right from design stage, you give it to your in-house design team or your subcontractor design team, and that think, will this part need service? Many people have an attitude to say, a tank टूटेगा नहीं तो नया कैसे लेगा? I don't think in the long run that's the right attitude. If your customer grows, you grow with him. Don't forget that. Make friendships the most important part. That lasts lifetimes. You have to be hands-on for most of the things. You have to be able to help him, guide him, whether it's electrically, whether it's process or the PLC, because sometimes it could be a process problem that doesn't concern you. And you say, no, I'm the machine guy, or I am the polymer guy, and I have no idea what you did, and you did something wrong. Well, if you think a little bit, get into his shoes and see how you can guide him and solve the problem together as one team, you cannot go wrong. You are linked with your customer forever. I think there is no presentation which would be complete without new products. Everybody likes to see new products. So here are some interesting products, and whatever I'm showing you is with permission from the manufacturers. So there's no problem there. This is, it's called a glut. It's actually polyethylene encased with steel tubing. This coil is weighing 9.5 tons, and it is sitting on a rotomolded part. This is a conveyor cover used in the mining industry. Again, very popular in all modern mines or upgraded mines because they cannot allow expensive ore losses or water contamination from rain. This is a jetty. A jetty. Sorry. This is a jetty to walk on water. Again, earlier I showed you the kiss-off in this jetty. These are floats for the marine floats. This is double-walled farming bins and boxes. This is, of course, a very essential commodity today, the mobile toilet. Everybody likes to think out of the box, or should be thinking out of the box. Where are we in thinking out of the box? I think we are far away. Even though we are very experienced rotomolders, I think we are far away from it. Look at this. Is the audio there in this one, or this one also doesn't have an audio? Fantastic, isn't it? So this guy's really been thinking out of the box. In July last year, we had very heavy floods in our city, Vadodara. We had actually crocodiles running all over the place, including some major roads of Vadodara. The airport at the back, as you can see, is almost flooded. These crocs are in residential areas, lot of salvage stuff. And what was really short was rescue equipment. There was literally one rescue boat which could move around and trying to salvage people, and they really didn't know what to do. And crocs in the water, crocodiles, hungry crocodiles in the water, nobody was willing. Everybody was just wanting to sit in dry area on top of cars or on top of the first floor buildings. It gave us an idea of what the demand, or rather for what we should do for the society to try to help them in this kind of situation. So we started our project on a rescue boat from a 3D model to a mold to the product. And we have today the product, which is a 3.8 meter boat, which can carry 8 people comfortably. So this year, when we had the floods in that, we were ready to deliver everything that was required to the emergency services, disaster management services. Look what rotomolding can do, how and where you can apply it. It's really interesting. This is a floating dock in the middle of nowhere, where to work you require guards with AK-47s around you. Yet these people have done an excellent job. Big float. It's almost on the border of Congo. There's some interesting parts here. This is a wine tank for manufacturing wine, 5,000 liters together. Most people think that very good wines are made in excellent oak barrels. Oak is now in real short supply. And because oak is in short supply, what they do is, and environmentalists don't like you chopping down trees. So what they do is, they make the wine in this kind of container. in a small netted bag like you buy onions in the market. They put oak pieces in it, and then they hang the oak netted bag into the wine, and that's how you get your oak flavor. And a wine which costs maybe 75 rupees to produce per liter is bought by you at 750 rupees a liter, just to give you an idea. This part here in the middle is a very interesting part. It's made on our machine again. It's called a cool sport, high cool sport, because what it does is it conditions the athletes. So they fill it up with ice, and the guy is sitting inside it, and his body temperature has to condition it with ice, because they play football in even if it rains, snows, anything, or the temperatures are very, very low, even less than 0 degrees sometimes, they still carry on playing the game. So, and even for cricket, nowadays they play cricket in New Zealand everywhere in very cold temperatures. So the players have to be conditioned, and this is a conditioning bucket for them. Of course, planters, very good designs, imagination, there is no limit to it. You can make any size of planter, you can make it with lights, without lights, you can make it with water fountains in it, you can make actually a water tank with a planter on top. So you can fill up the water down here, and yet it looks like a planter. So these are some new products which normally people always like to hear about in that. This is a very, very challenging job on a machine in Germany. I was personally there to install and commission this machine, and it had 32 inserts in it, and it has a duct to be molded in plastic, which is running from inside up here. There's another duct coming from here, also down here. So there's a Y section here, there's a duct coming up here, and it has to form inside the mold. It was a nightmare, and that is the first mold he brought to us and said, I need to produce this. Until then, he had never even spoken about this. I said, my God, this is really going to be a tough job. Anyway, eventually on the second shot, we got it right, and it's good. We love our country. We must keep moving even in difficult times. And I would like to say a big thank you to ROMA and end this presentation on this note. You are welcome to come up with questions if there are any. Don't make it difficult for me. I may not be able to answer them. Thank you.
Thank you, Mr. Dhanu.
Any questions, anything, you're welcome.
Yes, sir. We will do.
Dhanu bhai, Mukesh.
Yeah, Mukesh, hi.
That pipe thing which you told, I was not able to get it clear. What is that exactly? That pipe which you showed, that heated pipe. What is the application and what is it about, sir?
When you want to make a solid plastic pipe through, let us say, a cylinder. When you want, this is your part, and you want to make a through pipe in this across. You cannot get heat and polymer in the center. So you put one of those heat pipes in there, inside the mold, and that will get conveyed. The heat will go in the middle of the mold, and you can form a pipe on it. It's called a heat pipe.
Thank you.
It works like a heat sink.
Okay, sir. Okay, sir. Thank you so much.
Welcome.
Yeah, good afternoon. Our FGC board directors, EC committee, and my dear Roma friends. I am delighted to welcome all for today's webinar. I thank very much Mr. Dhanu Patell from Reinhardt for giving a wonderful presentation and accepting ROMA request for today's webinar. He's given a presentation on a basic subject of back to basics. That was the need of ours for rotomolding technology. He has emphasized on for a successful rotomolders, the basic of rotomolding technology is very important. He has also shown a detailed things about the mold claims, the normal claims, the pneumatic claims for the different. He has also emphasized on the powder loading system for the multi-layer products, routers for cuttings and finishing operation for the regular job. Mr. Dhanu Patell has also given a presentation on a good manufacturing practice, and he has also emphasized for the palletized systems to be used for the material handling product in our shop floor. He has also shown us the different valve, control the valve thickness with the airflow, air amplifiers, and the design parameters and different design parameters to give the uniform valve thickness in the products. He has also emphasized the basic design concept for the designing the products for the kishops and the basic radius for the product designing for the better flow in the products. For the different uniform valve thickness, he has also shown us the different air amplifiers for the uniform heatings, for the air pockets. We can use the profit pins, and more surface area can be generated in the molds that will also help for the uniform valve thickness. He has also shown certain things on the bimetallic molds with the brass insert for the, especially for the ice boxes mold, and where the uniform valve thickness and a double valve container molds where the uniform valve thickness is required. That also give one motors to take care during the mold and product designing. Along with the basic product designing, he has also emphasized on the safety of our shop floor, how to guard our machines for the better safety, and especially for the multinational company, the big companies, the safety is the main important part. So that also definitely helps our molders to understand how to do safety and do the proper shop floor planning for their machinery. Along with this, he is also emphasized on the customer management and services and the new products for the roto moldings and the new applications. So it is a very important and very informative presentation for all the roto molders and the ROMA members for their day-to-day the software management as well as the customer management as well as basic product designing. I thank Mr. Patell for this presentation. I thank Mr. Yuvraj Singh from the Frontier Polymer to welcome our speaker to our welcome guest speaker, Mr. Dhanu Patell. Mr. Yuvraj is associate as a Mr. Yuvraj is associate from the beginning, from the inception of the ROMA. We request Mr. Yuvraj Singh to take initial part and support ROMA for the future development for roto molding industry in India. As you all aware that ROMA is always have the different opportunity for the ROMA members, and we are conducting the basic seminars, and this is the 16th seminar which we are conducting, and very good presentation was given by Mr. Dhanu Patell. We have almost covered our different topics like the designings, raw materials, molds, machinery, pulverizing, extrusion, custom molding products, testing, shop floor management, high-end aluminum cast, CNC machine bolts, and topic related to the testings with the world-class international and Indian speakers. We always try to give best services to our ROMA members by presenting the good speakers and they are the masters in their field, so that give the good support to ROMA members. Presently, the ROMA is arranging 2 webinars in a month and continuously arranging the webinars after this COVID-19. So we will continue our webinars and seminars during this lockdown period and post-lockdown period till the things are not normalized. And we'll bring the best speakers for this presentation. ROMA is also regularly updating their members about the different informations regarding the product developments, government structures, and the new applications, soft law management, and different status for the rotomolding applications and the new rotomolding applications about our ROMA members. We also give the guidelines for the new product standards and the government approvals. Now, we have just completed our 1-year journey. Now, in the coming years, we are going to give more emphasis on the different subject, especially during this thing. We will go for this. We have recently participated in the BIS standard, and we have submitted our revision in 12701 water tank revision to the BIS standard, and they have accepted our proposal. And this will be definitely a revision for the water tank market in rotomolding industry in India. So once the revision will be taken place, almost after 30-35 years that this revision is taking place. So it was a very old standards which we are following for the years together. Complete Reliance team, our BIS committee team, Manoj Patell and Dr. Mahajan, he has given the very good support for developing these standards, and we have presented to the BIS for the revision in these things. So in coming years, definitely it will be useful for all the water tank manufacturers in India. We are also going to work on the underground water tank standards with the BIS standards, and our BIS standard team is working on this subject, and definitely we'll work on this subject also. As far as another subject like the automotive parts and other standards, ROMA team is working on these subjects, and we'll work on development of these subjects. In coming years, I would like to say that now we become the third largest rotomolding association in the world, and almost 99 members are our registered member, and almost we have got 2 international members, and we have already started the international membership drive. A lot of inquiries are coming, and coming time we will have a lot of international members throughout the globe. So we request our members, members, and all that they can tell their fellow members who are in the rotomolding industry become a member of rotomolding industry. So we become a strong rotomolding association and represent to the Indian government as well as to the international platform for the upgradation of rotomolding industry in India. Gaji and Gaji Teng is already become member, and Mr. Chandu Shah from the Kenya, they also have our members. We already, our website is our live website, and you can take the advantage by giving the advertisement in this thing and promote your products. You can see our website, the different the suppliers and other people, they can advertise, and this thing, the slot is available, and details can be available with our advertisement team. You can also sponsor the webinar and seminar, and you can take advantage for the business opportunity for this thing. Now this year we are working with the we are working on the skill development things. I am going to put this one slide, that one. This year our target for the skill development for the manpower who are used in our rotomolding industry, the PM message is there for the skill development for the things. So we are working with the Council of Skill Development, and in this contest, Mr. Vinodji from the Reliance Industries, they are supporting us to work with the government of India. So this year our more emphasis for the skill development of our people. So we will come out with our proposals this very soon with the skill development people. We'll call the directors from the skill development organization, They will come, they will give the presentation, and definitely will work. ROMA and the skill development department will work together for the betterment of the rotomolding industry in India. Now, if you can see the chart on the screen, now if you see from the Jan 20 to the September 20, you can see the now our economy is coming back to the normalcy. Almost there are many. If you go in the manufacturing PMI, we have got some data where in the September almost things are become greening. We have almost reached to the January data in the manufacturing to the 56.8 in September 20. So normalcy is coming, business are growing, rotomolding industries are also growing, unemployment rate is also decreasing, the mobility in the drivings, things are also better. So now it is upcoming market for our industry. We can work together after the post COVID and lot of new applications and products. ROMA can help to develop for the ROMA members for this one. You can enter in the automobile sector, the material handling products are the health care safety products are there, water tanks, underground tanks, lot of new products are coming. Definitely it will help to increase the economy for the skill development. We have already worked on. So we at this moment I will also say thanks to our sponsors who are regularly supporting us, M Plus, Kaveri, Turbo, Model, Aryan, Puja Rotomat, News, ML Industry, and Swastik Rotomatic and Reliance Industry. They are always supporting us for our programs and all webinars and seminars from the complete years. So we thanks to our sponsor, and we also request our fellow members and suppliers members to come forward and sponsor their program and do the marketing for their business platform. The region suppliers are always supporting us, especially we thanks to the GAIL, Reliance Industries, Indian Oil Corporation, HMEL, Opal, and Haldia. They always also support for our ROMA activities. As you know, the first annual ROMA meeting was held in last week, and as we promised that our association is purely democratic and transparent, and that we approved in 1 year. We have very democratic way and very transparent way. We have published our balance sheets and profit and loss account, and that is circulated to all the members, and soon it will be published in the AGM meeting. So in that way, whatever ROMA is promising, we are fulfilling our requirement to all the members, and all the things are very systematic and democratic way we are working. So we request all of them to come forward and take initiative to take part in ROMA activities. Our next webinar will be held on 28th October. This time it will be held on Tuesday, because this Saturday and Sunday, next Saturday and Sunday, it will be the Dasera Puja. So the next webinar will be held on 28th October. The timing will remain same. We will publish the name and the speaker for that occasion. So you can save the date for that one. Soon we will give the speaker name and the topic for the thing. I once again thanks Mr. Dhanu Patell, Mr. Yuvraj, and I would also like to thank Mr. Sunil Gupta, who is recently joined in the last AGM meeting, and he has taken that he's going to participate. He's taking care of our Eastern Zone. So I thank Mr. Sunil Gupta for taking this responsibility, and he will take in the Eastern Zone today. He is present here. He thanks the completion of our webinar. I thank all the members once again, and now request Manoj Bhai to take care of the question and answer. So we can start now question and answer. Manoj ji, please take care.
Yeah, thank you, sir. Thanks a lot, Dhanu sir, for excellent presentation. Many thanks for your outstanding presentation and accepting our request for ROMA webinar. And you have covered all the points very well, like processing, machinery, molds, best practice in on shop floor, safety, new opportunities. Now webinar is open for questions and answer session. You may ask questions directly to Dhanu bhai. First question is from Mr. Sudhi Jain of Arihant Roto. I think Sudhi Jain ji is here. Mr. Sudhi Jain, you can ask directly to Dhanu sir. Hello, Sudhir ji. Hello, Sudhir ji. Are you here? Hello,
Manoj ji, he is there, but he is on a mute actually.
Sudhir ji. Okay, I will ask his question. Dhanu, he is asking what kind of floor where we have demolding. It should be RCC floor or brick floor. Dhanu sir.
Best is what kind of floor really doesn't matter as long as it's dust free, it's painted, and you have a rubber mat on it.
Okay.
If it's a brick floor, you will have always dust and brick peeling and coming out. So best floor would be epoxy, but it's expensive. So you can take a IPS cemented floor and paint it with floor paint. And then in the area where you're dropping your parts, you can put a 20 millimeter, 15 millimeter rubber mat and you'll be okay. But the minute the part is out, it should not come in contact with dust or a cold floor. And it should go on to a pallet truck or a pallet.
Gary want to say something? Gary?
Yeah, I agree with Dhanu, what he said, and he showed in a slide. I'm a very big believer of putting things straight onto wooden pallets, or definitely not on the ground. So most factories, the guys can't afford to keep their floors clean and tidy, and so if you've got it on wooden pallets, it takes the dust away and gets it off the cold. But never ever place it flat onto a cold, dusty floor, as Dhanu said. Thanks.
One question is from my side. Dhanu sir, we want 25 KL machine demo video. Can you give us some video of a 25 KL machine?
I'll have to ask my customer, but yes, I suppose if he says okay, I can give it.
Yeah, because of we are getting requests from many customers so that they want to convert this open flame to closed zone machine. So
it depends what is the output that they want. If they want, let us say on an average, 10 tanks in an 8-hour shift or 8 tanks in an 8-hour shift, then yes, you can look at a biaxial or automatic machine for 25,000 liter. The problem is they may require 5 tanks or 10 tanks in a month.
Yeah,
that is where the problem is.
Yeah. Any more questions?
Very good presentation, Dhanu.
Thank you, Gary. Quite a lot of input is from you. I've learned a lot from you guys like you. It's all compliments to you all.
Yeah, and we learned from you as well. Thank you.
Okay.
Dhanu sir, I want to say. Dhanu sir, I want to share something that 52 participants are directly attended this this webinar, and 26 participants are attending through virtual from Reliance Industries. So in total, 78 participants are attending this webinar. This is very good to say that ROMA webinars are very good, and your presentation is really very good. We are getting a remark from many persons that you have covered all the points. So this is a very good. And for this, I am handing over to a vote of thanks for Mr. Sunil Gupta. Sunil Gupta ji, are you here? Yeah.
Yes. Thank you. Thank you, Manoj ji.
Yeah. Over to you.
So, thank you, Mr. Dhanu Patell. It was a very interesting presentation by you. I thank all perspective members also. And today, very good news that I received a membership inquiry from a Nepal manufacturer FGC member. I'm in Ranchi, Jharkhand. So I feel honored and privileged having an opportunity to offer a vote of thanks on this memorable occasion. The presentation of Mr. Dhanu Patell, I think it was a very basic, starting from very basic basic fundas to very new innovative things which we learned today. And he showed us the rotational ratio charts, which is the wall thickness chart. And he started with the good manufacturing practices, which we were lacking, I think. And it's a good opportunity during this lockdown period that we are learning new things. And Reinhardt Group is a very well-established, world-famous name in rotomolding sector, and have business in almost all the major countries across the globe. I am also keen to work with you. Thank you, Mr. Dhanu Patell, and thank you, ROMA members. Very soon we'll be meeting again on 17th webinar on 28th October. So thank you, all of you.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir. Thanks a lot.
Thank you all.
Thank you for so many kind words.
Thank you, Dhanu bhai.
Okay.
Thank you.
All right.
Thank
Cheers.
you.
Bye.
Yuvraj ji,
Bye.
thank you.
Thank you,
Thanks.
Sunil
Bye,
ji.
guys. Bye.
Sunil ji, thank you. Gary, thank you, sir.
Gary ji, thank you.
Enjoy your Saturday afternoon lunch. Bye.
Yeah.
Yeah, sir. Thanks, sir. Thanks.